Hi, welcome to this lesson on number patterns, finite geometric series. Let's have a look at question 6 on solving a finite geometric series problem. We want to solve for k here in the following series. K plus 1/3 k plus 1/9 k plus all the way up to this last term here, 1 over 19,683 times k. And we're given what the sum is. It's 7,381 divided by 6,561. Okay, so where do we start? Well, let's check that it's geometric. So it must have the form a times r to the n minus 1, where n is a natural number. Well, the first term a is just this first term here, which is the letter k, this variable. And it looks like we're multiplying by a third each time to get to the next term. So my common ratio r is 1/3, which is really important because it's less than 1, which kind of indicates to me I'm probably going to end up using the second formula when we try to solve for k here. Okay, so let's write what we know. The sum of however many terms are here, because we don't actually know how many terms are here, is a times 1 minus r to the n all over 1 minus r. So let's see what we do have. We have a, which is k, that's what we want to solve for. So a can be the only unknown in this equation when we want to use it. We have r, which is a third. That's great. But we don't know what n is yet. So we can't have two pieces of missing information here. We can only have one because it's one equation, and we want to solve for one variable. So how do we get n there? Well, let's see. We know this is a geometric sequence. So therefore, the final term, so if I write it, a is k times 1/3 to the n minus 1. Well, we want to know when is that the last term. That last term is 1 over 19,683 times k. So essentially, we want to solve this equation for n here. Okay, so because k is on both sides, I can just divide both sides by k. And therefore, I have 1/3 to the n minus 1 is the same as 1 over 19,683. Now, we are solving an exponential equation here again. So the two techniques are, can you match the bases? Because if we can match the bases, we just equate the exponents. But I can get lucky on my calculator and see maybe 3 to some high power might give me that 19,000. Let's try 3 to the 5 first. 243, not high enough. Let's try maybe 3 to the 8. 6561. Nice and interesting that that number pops up here and it's in the question. So that's probably a good track for us. Let's try another one. Let's say 3 to the 10. Ooh, 59,000. That's way too big. So we tried 8 and we tried 10. So let's try 9. Oh, isn't that lovely, right? So therefore, this number here is 3 to the power 9. So therefore, you have 1/3 to the n minus 1 equals 1 over 3 to the power 9. But we can rewrite that using exponential laws. That can be written as 1 over 3 all raised to the power 9. Because the bases are the same, I can therefore equate the exponents. N minus 1 equals 9. And if I add 1 to both sides, I get n equals 10. So this tells me that there are 10 terms in total here. First term, second term, third term, all the way up to the 10th term. But let's say now you didn't think about matching the basis 3 there. And perhaps maybe 19,683 wasn't a base of 3. You know, just taking as an example, maybe it was a different number and it wasn't a base of 3. How would you solve it? So alternatively, so if we want to solve this equation here, we would use logarithms. So remember, to get rid of this 1/3 here, and just to leave you the exponent n minus 1, you take log base of that base there, which is 1/3 of the value 1 over 19,683. So therefore, n minus 1 equals, let's pull up our calculators, log base 1/3 of 1 over 19,683. 9. Perfect. Because then you get n equals 10. And that's exactly what we had the first time. So, try your luck the first time. See if maybe that big weird number on the right-hand side can be matched, right, as a power of, in this case it was 3 here in the denominator. But sometimes you might not be able to. And in that worst case scenario, logarithms are always going to get you out of that pickle. Okay, because they'll always be able to answer an exponential equation for you, regardless of the base. Well, obviously we have those restrictions, which you can see in the logarithm lessons, but logarithms will help you solve exponential equations when you can't really match the bases. Okay, so now we know n, it's 10 terms. So let's go for it. The sum of the first 10 terms can be written as a, which is k, times 1 minus r, which is a third, raised to the power 10, all over 1 minus a third. Okay, and that equal to, we were told that's equal to 7,381 all over 6,561. So what I'm going to do is just clean up this left-hand side a little bit. So I'm going to leave the numerator as it is, 1 minus a third to the power 10. But the denominator is going to be 1 minus a third, which is 2/3. That's equal to 7,381 over 6,561. Okay, but now, how do I get rid of this 2/3 in the denominator? I need to multiply both sides by 2/3. So that gives me 2/3 times 7,381 all over 6,561. And then how do I get rid of this entire multiplication factor here on that k? Well, I simply divide both sides by that entire number. So I've done all the algebra in one step. I can go to my calculator now and put it in very carefully. In the numerator, we have 2/3 multiplied by 7,381 over 6,561. That was the numerator term here. In my denominator, I had 1 minus, open brackets, 1/3 raised to the power 10. Oh, lovely. That simplifies down to such a nice number, k equals 3 over 4. So there's our final solution, k equals 3 over 4. How do we know that that is correct? Well, we can have a check, right? So let's just clear everything here. What we found, S sub n, was that k was 3/4. That's what we solved. So remember, it's a times 1 minus r to the n over 1 minus r. We know that a, which is our k value, is 3/4. That's what we solved. R we worked out was a third, and n we calculated the sum of 10 terms. So if I plug all of that in, S sub 10, that is 3/4 into 1 minus 1/3 raised to the power 10, all over 1 minus a third. So all I did was just plug in the values for a, r, and n there. And let's go ahead and see if we get that sum that was there on the right-hand side. So 3/4 into 1 minus 1 over 3 raised to the power 10, all over 1 minus a third. And if I do that, I get 7,381 over 6,561. And that was the term on the right-hand side. So therefore, the value that we've solved for k is the correct value for this series. And that's how we would solve this type of problem. Lots of algebra going on. Knowing your rules, especially your exponential rules, and knowing how to work with logarithms is extremely important whenever you solve any type of geometric problem in sequences and series. Okay, I'll see you in the next one.